हेलो स्टूडेंट्स, वेलकम बैक टू द क्लास। लास्ट क्लास में हमने डिस्कस किया था कि हॉरिजॉन्टल एक्सिस विंड टरबाइन का हॉरिजॉन्टल एक्सिस विंड टरबाइन के बारे में वी हैव डिस्कस्ड अबाउट द ऑपरेशन एंड वी हैव डिस्कस्ड अबाउट द वर्किंग। नाउ in this lecture we are going to discuss about vertical axis wind turbine power plant and the block diagram of wind energy generation. Okay, so let's get started. Firstly, here you can see in figure 2.1.6, this is vertical axis wind turbines construction. There are different types of construction. That the first one, which you can see, it has only one blade and it is slightly curvy, rotated. दूसरा जो है वो इसके अंदर you can see two blades. Mostly जब vertical axis wind turbine की बात होती है तो you will see the turbine with two blades often. और तीसरा है जिसके अंदर you can see three blades. Okay. Now coming towards construction and working. So इसमें क्या होता है कि जो मेन रोटर शाफ्ट जो रहता है उसको हम वर्टिकली अरेंज करते हैं एंड दैट इज़ वाई इट इज़ कॉल्ड वर्टिकल एक्सिस विंड टरबाइन. ओके, लास्ट लेक्चर में व्हाट वी हैव डिस्कस्ड, इट वाज द रोटर शाफ्ट वाज हॉरिजॉन्टल and in this one it is vertical, and because it is vertical, okay, because it is vertical, the power which uh, will be generated when wind will come from any direction. Like पिछले वाले में we have to be careful. Like पिछले वाले में क्या था, we have to arrange the yaw angles and all to get best efficiency in horizontal axis, but vertical में अगर wind कहीं से भी आ रही है we will be able to generate power from it, and because it gives us freedom to generate power like that, इस कंस्ट्रक्शन में वी डोंट नीड एनी यॉ मैकेनिज्म. ठीक है. सो जो टर्बाइन शाफ्ट जो होता है इट इज़ coupled to the generator and gearbox, either with the gearbox or with a direct drive as well, with the control unit, and generator converts the mechanical power provided by wind turbine into electrical power. Now इस टर्बाइन में कैच क्या है कि इट कैन ऑपरेट इट एट वेरिएबल स्पीड, जिसकी वजह से मैक्सिमम पावर आउटपुट आपको मिलेगा, प्लस इट ऑफर्स इट ऑफर्स वेरिएबल स्पीड एंड ऑप्टिमाइज्ड पावर आउटपुट ऑपरेशन जो बिल्कुल लो नॉइस पे होगा. एंड व्हाट आई जस्ट मेंशन बिफोर कि यहाँ पे पिच एंड यॉ जो है वो कहीं आता ही नहीं है, बिकॉज हमारा जो शाफ्ट है वो पूरा वर्टिकल है. सो किसी भी डायरेक्शन से विंड आएगी विल बी एबल टू जनरेट पावर. सो यॉ एंगल एंड पिच गेट्स एलिमिनेटेड, राइट. जो मेन कंपोनेंट जो है टरबाइन के वो सारे ही बेस पे, मतलब बिल्कुल बिलो, like let me show you the picture again. You can see the base here, here and here. तीनों में ही जो बेस है, तीनों ही पिक्चर्स में जो बेस है वो एकदम नीचे है. So when fault occurs, the person who does the work, engineer, will be able to access that location very easily. So service और maintenance जो है वो easy हो जाता है और वो compatible भी हो जाता है compared to horizontal axis wind turbine. Okay, now aerodynamic force is resolved into lift and drag components which maintains dynamic pressure. ठीक है. और दो तरीके के टरबाइन यूज़ होते हैं, डायरियस टरबाइन और सिवोनियस टरबाइन इन वर्टिकल एक्सिस विंड टरबाइन. ओके, Now discussing their advantages. फर्स्ट ऑफ ऑल कि कहीं से भी हम विंड का डायरेक्शन जो है मैटर नहीं करता इस टाइप के टरबाइन में. विंड कैन बी पावर कैन बी जनरेटेड फ्रॉम it doesn't matter, like direction of wind doesn't matter. You can generate power if wind is coming from north to south, blowing from north to south or south to north or west to east, east to west. It will not matter. Okay. प्रोडक्शन कॉस्ट जो है वो काफ़ी कम रहता है कंपेयर टू हॉरिजॉन्टल एक्सेस विंड टरबाइन का, बिकॉज वी हैव जस्ट मेंशन कि जो पूरा टावर जो कंस्ट्रक्ट करना पड़ता है और उसके ऊपर साथ में पूरा जो मैकेनिज़्म है उसको इतना ऊपर एक बेस बना के आपको बनाना पड़ता है, विच इज़ नॉट द केस हियर. सो प्रोडक्शन कॉस्ट घट गया, and with that construction is easy because you don't have to operate at such height. Your base is on the ground, so construction easy. Plus because base is on the ground, the maintenance gets easier और ट्रांसपोर्टेशन में इतना कॉस्ट नहीं होगा. ठीक है, बिकॉज अगर मेंटेनेंस करने इंजीनियर को जाना है in horizontal axis wind turbine, you have to get him over there at that height. Yeah, they do use lifts in few windmills, few power plants, but still the cost is way too high. Okay, which is very less here because you just have to walk in and operate and walk out. Okay, then yaw and pitch control mechanism are eliminated. We discussed this point before. It is suitable for extreme weather conditional areas because जो हॉरिजॉन्टल एक्सिस विंड टरबाइंस रहते हैं उसमें क्या होता है कि जब बहुत ही ज़्यादा विंड स्पीड बढ़ जाती है तो you have to apply those brakes, electromagnetic blades, which is not the case. It is okay if wind speed exceeds. Okay, and it provides variable speed operation. Now you may doubt अगर इसके इतने ज़्यादा advantages है, then why don't we use it in real life? Because why do we see all the horizontal axis wind turbines? The major reason is efficiency. The efficiency of vertical axis wind turbine is very less because of its variable speed operation and because of wind direction and all that. So efficiency is very less and relatively high vibrations because airflow needs to ground create airflow near the ground will create turbulent flow, right? So there will be relatively high vibrations because of that airflow, and because of the turbulent flow there will be less generation, right? Now let's see construction. Here's the image in which you can see my vertical axis wind turbine. This this curvy things are blades. This is bladed wind turbine. Okay, then this is the shaft. It is vertical, as you can see. Here are the bearings, this one and this one for my blades. Okay, here's the lower platform. Blades required to be placed at such some height. उसको बिल्कुल हम नीचे नहीं रख सकते हैं, ठीक है. This is the upper platform separated from bearing. यहाँ पे जो है हमारा gear box आएगा. Then there is a generator below it. Okay, again here's a platform and bearing, and between them there are disc brakes. Situation occurs and brake is required to be applied. Here's the disc brake, and this is the foundation of my whole structure. Okay, and last में there are guy ropes. One rope or two rope called guy rope is put it over there. We will be discussing its application further. Now, in the top and bottom bearing, vertical shaft is supported. I just showed you. This is the vertical shaft, and this is the top and bottom bearings. This is the top bearing. This is the bottom bearing, and the height of the tower is ideally 100 meters, and the blade section is aerofoil, which we have just discussed in disadvantage section. Oh, sorry, we haven't. Sorry. So, blade section is aerofoil. Then, the vertical shaft of the turbine, this one, which is coupled to the generator shaft after the gearbox. Here you can see, and there are disc brakes, which helps us in braking mechanism. Now, how it will be generating energy? Wind energy will rotate the blades of the turbine. Okay, and as these blades will rotate, the turbine rotor will start rotating. Okay, and as this turbine rotor will start rotating, the gearbox will rotate. Okay, and gearbox will amplify its rotation in one point, and after that, what will happen? It will uh, cause the generator to rotate. It will provide mechanical input to generator in form of rotation. And it will generate electricity. It will convert mechanical energy to electrical energy, the generator. Okay, now coming towards the block diagram of wind energy generation. Is a block diagram. Here you can see there are rotor blades, and we receive wind energy from rotor blades. Rotor blades will come in direct contact of the wind, and it will start rotating. When rotor blades will rotate, it will cause gearbox or drive mechanism to rotate, and based on gearbox, our generator will start rotating. Okay, and as generator will rotate, it will convert mechanical energy into electrical energy. And now this generated energy which has generated right now will be not destabilized. Okay, so we will need power converter to stabilize it. So we will use power converter to stabilize that energy, and then it will be supplied to the grid or the AC load. Okay, now you can see in this portion we are dealing with mechanical energy. Okay, and once generator comes into the picture, after generator part we are dealing with electrical energy. This energy which were supplied to the grid will be used by us. It will be like transmitted and available for utility. Okay, now coming towards the application of wind energy. There's low power wind energy generators which are used for space heating, cooling of homes, domestic application drives, appliances drives. Okay, उसके बाद हाई कैपेसिटी टर्बाइन मैकेनिज्म्स होते हैं, मशीन्स होते हैं जिनको इरिगेशन पंप्स के अंदर यूज़ करते हैं, नेविगेशन सिग्नल्स में यूज़ किया जाता है. ओके, ऑयल ड्रिलिंग में यूज़ होता है. देन देयर आर जनरेटर्स बिटवीन 100 to 250 kilowatts जिनको जो आइसोलेटेड पॉपुलेशंस है वहाँ पे अगर आपको इलेक्ट्रिसिटी सेंड करनी है, या छोटी इंडस्ट्रीज़ में उनको खुद का प्लांट चाहिए, तो वी यूज़ बिटवीन 100 to 250, लाइक वो एक तरीके से आपका खुद का एक एनर्जी जनरेशन मैकेनिज़्म हो गया। और उसके बाद जो वेरी लार्ज जनरेटर विंड पावर प्लांट्स है उसको हम लोग यूज़ करते हैं ग्रिड सिस्टम के साथ, इंटरकनेक्टेड जो ग्रिड सिस्टम है उसके साथ हम कनेक्ट कर देते हैं। So it directly gives supply to grid, not directly after using power converter, but ultimately it gives supply to grid. Okay, now state wise potential of wind potential of states of India कि पहले देखिए, अगर हमने वी डिस्कस दैट तमिलनाडु जो है वो काफ़ी ज़्यादा अच्छी एनर्जी प्रोड्यूस कर रहा है, and Gujarat is second. Then, but actually, if you see like the states who have greater seashore, like Gujarat and Maharashtra, have more gross potential to produce more wind power. Okay, so the gross potential of Gujarat, you can see 9,675, because Gujarat has the biggest, longest seashore of India. Okay, they have 1,600 kilometers of seashore, so they have more capability. And same ways, West Bengal and Kerala, they have 875 and 450 gross potential, 450 megawatt gross potential. Okay, same way you can see technical potential, which is very high for Maharashtra. Okay, and same for Andhra, but it is very low for West Bengal and Odisha. Okay, dear students, so we will keep the lecture till here. We will discuss about wind turbine components and wind energy conservation in the next lecture. Till then, take care. Bye bye. Thank you very much.